In this section, we are going to discuss about the heteroscedasticity problem. And we learned that one of the important assumptions of classical linear regression model is that the disturbance term ui appearing in the population regression function are homoscedastic. That is, they all have the same variance. That is, expected value of ui square equal to sigma square. And the heteroscedasticity is the unequal variance, and it is denoted as its expected value of ui square equal to sigma I square. This we already discussed. This is the assumption. Homoscedasticity is the assumption, and heteroscedasticity is the violation, or it is the unequal variance. And in this section we are going to discuss about the heteroscedasticity problem. What is the nature of heteroscedasticity, what are its consequences, how to detect it, and what are the remedial measures are discussed in this section. And the diagrammatically we have to say this is the diagrammatic representation of homoscedastic disturbance term. Here the variance are equal, the variance of the disturbance terms are equal, and if the situation of heteroscedasticity prevails, the graphical representation will be here like this. Here the variance of all the observations are, all the error terms are different, and here the causes or the sources of heteroscedasticities are given. That is, there are several reasons for the or the causes or the sources of heteroscedasticities. When first one is when the data set has a large range of observation, there is a very possibility of heteroscedasticity. Second one is error learning model. Here this error learning model means as people learns, their error becomes smaller and smaller. That is, in this case sigma I square is expected to decrease. As an example, in the above figure, in this figure we know that here the variance as the people learns more and more, their error decreases and the variance decreases. That is, in this case the variance will be different. That is the error learning model. Then next one is the data collection techniques. Data collection method means that as the data collecting techniques improve, sigma I square is likely to decrease. That is, if we uses better data collection method, there will be variations in the variance of the different categories of the people. In that cases also heteroscedasticity may occur due to the presence of outliers. That is, the presence of outliers also causes the problem of heteroscedasticity. Here outliers means some of the observations will exist away from the, or it will be like a stranger in the data group. That is, the existence of this the data like this will create a problem of heteroscedasticity. That is the presence of outliers. Then if model is not correctly specified, then also there will be problem of heteroscedasticity. Skewness in the distribution of regressors is another important reasons for the heteroscedasticity. That is, the skewness in the distribution of one or more regressors included in the model. Then incorrect data transformation. If we use the transformation methods for the data, if we use this incorrect transformation, then there will be heteroscedasticity. Incorrect if the functional form used is not correct, then also there will be the problem of heteroscedasticity. That is, the important reasons, causes, or the source of heteroscedasticity is that first one, when the data set has a large range of observation. Then error learning models. In the case of the error learning models also will have different variances. If the data collection method improves, or the techniques of data collection method improves, then there will be the problem of heteroscedasticity. Then the presence of outliers also creates the problem of heteroscedasticity. If the model is not correctly specified, if the data transformation model is not correct, if the functional form is not correct, then in all these cases there will be the problem of heteroscedasticity. Skewness in the distribution of the regressors also creates the problem of heteroscedasticity. Now the OLS estimation in the presence of the heteroscedasticity are given here. One of the problem of the OLS estimation, the problems in the estimation of model in the presence of heteroscedasticity are that the OLS estimators will be linear, be unbiased, but the variance will not be minimum. That is, the blue property will not be satisfied in the case if there is heteroscedasticity. that is the Euler's estimators are linear. This is the linear the proof of that we have already seen, and the unbiased properties also will be satisfied in the case if there is heteroscedasticity. But the problem is with respect to the minimum variance, and here the homoscedastic variances are given. This is the homoscedastic variance of the LS estimators, that is variance equal to sigma square by sigma xi square. If we have heteroscedasticity, the expected value of ui square equal to sigma I square, that is variance of beta to cap equal to sigma ki square sigma I square, where ki equal to xi by sigma xi square, then this will be equal to sigma xi by sigma xi the whole square into sigma I square, that is sigma xi by sigma xi square into sigma I square. This will be the variance. Since the variance is not minimum,